All right, we're trying to show that triangle EBD is an isosceles triangle, and EBD is this big one in the middle, sort of, which I just pulled out. So naturally we ask, how will we show this triangle is isosceles? And the answer is, if we can show that side BE is congruent to BD, then we will have proven that the triangle is isosceles. They've given us that angle 1 is congruent to angle 5. They've also given us that angle CDE is congruent to angle AED. CDE is this rotation, the green one, and that's congruent to angle AED, which is this green rotation. All right, well, notice that these green angles are part of a bigger triangle that's overlapped. So let's draw those two overlap triangles. And when we redraw those triangles, ADE and CDE, and include those green congruent arcs in the red ones, we can see that we can probably show that those two triangles are congruent. Notice that they share side DE. So clearly that side is congruent to itself by the reflexive property, and therefore this triangle is congruent to this triangle by the angle side, which is congruent to angle side. So we need to name the triangles that are congruent by the angle side congruence idea, and we can call this however we want to. I'm going to call it AED, and that went in the order of red arc, green double arc, black segment tick mark. AED. And now we need to name this triangle in the same corresponding order. So AED was red, green, black, so red, green, black. Or single arc, double arc, tick mark, single arc, double arc, tick mark. CDE. Well, how's that going to help us? We're trying to prove that triangle EBD, this blue one here, we're trying to show that that's isosceles. We're trying to show that segment BE and DE are congruent, and that is therefore isosceles. But side BE and BD aren't even in this picture. How are we supposed to get to side BE and BD? Well, now that we've used the given, including these green angles, CDE and AED, we're able to use that to prove that these triangles are congruent. Maybe now we can prove that the butterfly wing triangles are congruent, because if you look at the butterfly wings, side BE is a side of this butterfly wing, and BD is a side of this butterfly wing, and BE and BD are the sides of our triangle that we're trying to show as isosceles. So if we can now get to the butterfly wing triangles being congruent, we will be right on the verge of solving this puzzle. Since they don't overlap at all, I'm not going to try redrawing them. But if you wanted to, you could. All right, well, we've got these angle 2 and 4, which we didn't need to draw that to figure that out. 2 and 4 are congruent, and they're angles of these triangles. And why are they congruent? Well, they're vertical angles. All vertical angles are congruent. You could say all vertical angles are congruent, or the vertical angle theorem. Let's mark that in our picture. In this picture, I've already used 2 tick marks and 1 tick mark, so I'll use 3. But in this picture, I haven't used anybody yet. All right, we did know that angle 1 was congruent to angle 5. Let's go ahead and mark those. That was already given. We've got so much. We only need one more congruent pair of parts to prove that these triangles are congruent. And remember, once we do, corresponding part BE and BD will probably be congruent, which will prove that this blue triangle is isosceles. All right, well, how can we prove that these triangles are congruent? Do we have another piece? Remember, we proved some triangles were congruent above. What about side CD? Oh, that is a side of this triangle. And what corresponds to CD? AE. Aha! So because we proved these triangles were congruent using this piece of information that was given, the green triangles, which was the clue to draw the triangle that had this whole rotation, which was triangle DAE. Since we've got that, we can now use the definition of congruent triangles, which says their corresponding parts are congruent. You know, CP/CTC. So we're going to show that CD is congruent to AE because first and second corresponds to first and second. Here we go. Side AE, first and second, is congruent to side CD, first and second, because these triangles here are congruent, and we all know that corresponding parts of congruent triangles are congruent. So we can mark that in our picture, side AE and CD. And now we can prove that these triangles are congruent by side, angle, angle. You can call it SAA or AAS, it doesn't matter. All right, we'll call it ABE. And if we go ABE, that was the 2 arcs, 1 arc, we'll have to go 2 arcs, 1 arc, CBD. All right, and now that those triangles are congruent, remember what we're trying to do. What was our destination? Showing that this blue triangle, EBD, is isosceles. And how will we do that? We'll show that these sides here are congruent. And is BE congruent to BD? Well, look at this congruent statement of these triangles. BE is second and third letter. And who does that correspond to? Second and third letter, which is BD. Segment BE is congruent to segment BD. Exactly what we needed. Those are corresponding parts of these congruent triangles, and corresponding parts of congruent triangles are congruent. Well, we've shown that side BE is congruent to BD. That means this triangle EBD must be isosceles. We finished this proof. What's the reason? Well, we showed that these two sides are congruent. And that's the definition of isosceles triangle. If two sides are congruent, then it's isosceles. So it's isosceles by definition. That is how we do number 11. It's number 11 on the pink worksheet. For some reason right here it says number 10, but it's number 11. All right, I hope that helped.